Page 328, question 4A. Each car in a freight train experiences a drag force of 600 newtons due to air resistance. A, if the engine in the train is to pull 75 cars at a constant speed of 72 kilometers per hour, what power is required to move the cars? So we have a force of 600 newtons per car, and we have 75 cars. So to get the total force, we're going to have to multiply the force per car by the number of cars. Our velocity is 72 kilometers per hour. So it's going to be 72 over 3.6 to get meters per second. So in this case, work is equal to energy. So we're going to have force times distance equals power multiplied by time. Now, you're probably wondering, where does my velocity fit in if I have meters per second? Well, we have meters here, seconds over here. So when we rearrange this, we're going to get power is the force multiplied by the distance divided by the time, and V equals D divided by T. So our force is 600 newtons per car times 75 cars multiplied by our distance over time, which is 72 over 3.6 meters per second. So 600 newtons times 75 cars multiplied by 72 divided by 3.6 gives me 900,000 watts. So that's going to be 9.00 times 10 to the power of 5 watts. Part B. If the engine operates at 15% efficiency, what must be the power generated by the engine to move these cars? So we figured the output energy or power has to be 9.00 times 10 to the power of 5 watts or joules per second. So we're working in terms of power, not energy. And our percent efficiency is 15%. So efficiency is the output energy divided by the input times 100%. Now in this case, we have the power, which is joules per second. So we'll be calculating the input power as well. So rearranging this, our input is the output divided by the efficiency times 100%. So our output power, what we're actually doing is 9.00 times 10 to the power of 5, and that's again joules per second, or watts. Our efficiency is 15%, and we have to multiply that by 100. So 9 times 10 to the power of 5 times 100 divided by 15 gives me a value of 600,000. So that is 6.00 times 10 to the power of 1, 2, 3, 4, 5, 6 watts. And that makes sense because our output power has to be smaller than our input power. So as a result, we do expect to get a larger exponent on our power of 10.